Hi, this is Dr. Khan. I'll be the instructor for this online Chem 110 class. Now, at the beginning, I wanted to tell you that all these lectures are based on 12th edition chemistry book, Chemistry, the Central Science, and 11th edition as well as 13th edition would be fine. Only even the older editions, I've seen those problems are about the same, but the question numbers are changed. So what I did is I uploaded all the assigned homework problems as well as their solutions. So that would help you to go over those problems no matter what edition you have. But one of the recent editions would be better, which means 11th, 12th, or 13th. And if you're interested in buying ebook, I have given you price as well as how to get to that site, and that's how you can buy the 12th edition ebook. And your access would be valid for 2 years from the date of purchase. I'll begin with the definition of matter. Matter is anything that has mass and that takes space. On the very left, you see atoms of an element. Like for example, if you look at periodic table, there are all these different elements are listed there. At this point, you may not know the name of each and every element, but as time goes on, you're going to know most of them. So atoms of an element, for example, if I have neon, its atom would be just like this, the way it's shown. It could be neon. Similarly, it could be argon. It could be helium. So those substances would have single isolated atoms. Now, you may have molecules of an element. For example, at room temperature, you're not going to see just one oxygen. Two of the oxygens would get bonded like this. So it would be the way it's shown in the figure. Same would be the case with Cl. Two Cl would get bonded like this. Two hydrogens would be bonded like that. So we're showing you in this picture molecules of an element. So elements could be just like single elements in a gas phase like helium, neon, argon, krypton, xenon, or couple of elements, same elements can be bonded together, give you a molecule of that element, which would be hydrogen, nitrogen, chlorine, fluorine, bromine, iodine. Now, different elements can give molecule of a compound. For example, two hydrogens and one oxygen would give H2O or water. Similarly, I can have 3, 4, 5 different elements combined together can form a compound. In the figure, you see that there is a central atom and 3 other different atoms. It could be, of course, many things, but BF3, boron trifluoride, is one of them. BCl3, boron trichloride. Now let's look at the very last figure. It's showing mixture of elements and a compound. As you can see, we have those single atoms, diatomic molecule like hydrogen, nitrogen, oxygen, and then you have these molecule which could be a number of things having altogether 4 atoms. Atoms are the building blocks of matter. So make sure you understand that every substance has atoms. It's pretty much like bricks make a building. Similarly, atoms make a matter. Each element is made up of the same kind of atom. For example, if you're looking at an iron rod, no matter what part of iron rod I examine, I would see the same kind of substance there, same kind of atom, which is the atom of an iron. A compound is made up of two or more different kinds of elements. Like for example, H2O, what you're seeing is here is a compound. It's made up of two hydrogens and one oxygen. And then you have these organic compounds, ethanol, ethylene glycol, states of matter. There are three states of matter: solid, liquid, and gas. In case of water, solid form is called ice. Liquid, we all know, is called liquid water. And in gaseous form, we call water vapor. This is the case with almost every substance. Now, what are the properties these different states of matter has? Solid has a fixed shape, fixed volume, incompressible, and particles are closely spaced and strongly held. Think about any solid around you. You'd find that it has fixed shape, fixed volume, and you cannot compress it because particles are already tightly bonded. Liquid has no fixed shape, unlike solid. So it takes the shape of the container where you pour in. However, it has a fixed volume. It is also almost incompressible. You cannot squeeze it to a smaller volume. Here, particles are less strongly held, for which liquid flows, but a solid doesn't flow. By flowing, I mean if you pour water on a table, you'd find that you'd see the trail of water from one end to the other end. So particles are not strongly bonded to each other. If they were strongly bonded, then a whole body of water would be moving from one part of the table to another part. There'd be no wet space on the table. Now gas. Gas has no fixed shape, no fixed volume. It can really fill in any shape, any volume. If compressible, you can compress a gas to a smaller volume. And why all these properties that gas has? Because the particles in the gas are loosely held. Here we're going to discuss about classification of matter. Now, matter is broadly classified into heterogeneous mixture and homogeneous matter. Heterogeneous means more than one phase. For example, if you have water and sand mixed together, just by looking at the beaker, you can find and quickly tell that there are two different phases, because sand would make one phase, which in this case is sitting at the bottom. So this is the phase due to the sand sitting at the bottom, and water is sitting on the top. So that's more than one phase, and that's why it's heterogeneous mixture. Homogeneous matter could be of following types. Could be pure element, pure compound. Like looking at periodic table, you'd be able to see all the elements. Now compounds, these are made up of combination of a number of elements. Like H2O, water is made up of two hydrogen and one oxygen. So that falls under pure substance, and that's under homogeneous substance or matter. Homogeneous mixture. This is not a pure substance, but it's the mixture. That means you add a few things together having different composition. Like salt and water. Water is H2O, salt is NaCl. So you mix them together. Why is homogeneous? Because you cannot distinguish salt from water once you mix them together. But you can separate them by evaporating. If you keep on heating it and evaporate water, then salt would be left behind. Separation techniques. There are three separation techniques that I would like to discuss. Filtration, is the first one, distillation and chromatography. In filtration, solid substances are separated from liquids and solutions. Now, what criteria you need to have for filtration to be applied? You need to have a solid and a liquid, and also they should not be soluble to each other. So in other words, you must have heterogeneous mixture. So on the left side, you're seeing the figure. I mean, that's how filtration is done. This is called gravity filtration, where solid would be retained on the filter paper. In filter paper, you have tiny pores or holes. So the liquid goes through it, but the solid stays on the top of filter paper. And that's how separation is done. Distillation uses differences in the boiling points of substances to separate a homogeneous mixture into its component. Think about, you have salt and water in here. Now, water boils at 100 degrees centigrade, but salt boils at a much higher temperature. Now, if you keep on heating salt water mixture, salt water solution, then since water is going to boil much sooner than salt, so you'd see bubbles of water evaporated, and water vapor would go through these condensers and it would be collected on the right hand side. That would be pure water. So if you keep on heating, pure water gets collected on the right hand side flask, and on the left hand side flask you'd find salt. So that's how you can separate salt from water in this case. And this kind of separation was possible because of differences in boiling temperature. Chromatography. This technique separates substances on the basis of differences in adsorption or sticking property on the solid surface. Now let me explain this to you, these experiments. What you are seeing on the far left is anybody can do this kind of experiments. You can get a piece of filter paper, the long ones or big ones, and you can cut it in small strips, the way it's shown in that figure. And you need to have an ink drop. Now keep in mind, this has to be liquid ink, otherwise this experiment is not going to work. And then dip one end of it in water. As water rises through this filter paper, it pushes that ink drop, and you'd find that ink drop would be separated, which appeared black would be separated into different colors. So that tells you about the composition of the ink drop. Ink drop that appeared black is really have different colored components, and water has pushed, when water pushes these components based on sticking properties, some of them would be going farthest away from the original location of the dot. The one which has strongest sticking property or adsorption property would be the one that would be remaining close to the original location of the ink drop. So in other words, separation is achieved based on differences in adsorption properties. Here we're going to define law. Law is a natural phenomenon without any exception. For example, apple falls downward. That's the natural phenomenon, and there is no exception. It doesn't move upward. If you keep on heating water, it's going to boil. That's also a natural phenomenon, your observation. So keep this in mind, that whenever we talk about law, we mean natural phenomena without any exception. Hypothesis. Hypothesis is a tentative model to explain a law, and theory is established model to explain a law. Now units for length is meter, for kilogram is kg. Now prefixes used in metric system, you need to know what giga stands for. Mega is 10 to the power 6, kilo 10 to the power 3, and then you have a deci 10 to the negative 1, centi 10 to the negative 2, milli 10 to the negative 3, micro 10 to the negative 6, nano is 10 to the negative 9, pico is 10 to the negative 12, and femto is 10 to the negative 15. So make sure you know these prefixes. Extensive property depends upon mass. Think about an object. The small mass of that same object would have a smaller volume, and larger mass would have larger volume. So think about a piece of iron. If I have this piece, this is the volume. If I have a bigger piece, that would have a bigger volume. So that makes sense. So that depends upon mass. Often we don't understand that why heat is mass dependent. Let me give you a simple example. Say I have boiling water. So that's boiling water. I already heated that water. And I split that into two portions of boiling water. You all know that water boils at 100 degrees centigrade. So let's assume that it's at 100 degrees centigrade. If I split that into two small amounts of water, smaller amounts of water, I would have, say, tiny beaker with water and fairly large beaker with rest of the water. Even though both represent water at 100 degrees centigrade, would you think that they would have the same amount of heat? Answer is no. You can prove it by using a small ice cube. If I put that ice cube in this bigger container that has larger quantity of water, you'd find that ice cube would completely melt. On the other hand, if you put the same ice cube in the tiny beaker, or even pour water from the tiny beaker onto the ice cube, only a part of the ice cube would melt. The rest would not melt. That would tell you the larger mass would have more heat energy, for which it's going to melt the whole ice cube. Now, intensive property. Intensive property doesn't depend upon mass. For example, the color. I may have red colored furniture. A tiny portion is also red colored. The larger portion is also red colored. So it doesn't depend upon mass. Same is the case with temperature. Now, I already gave you a similar example here when I discussed about heat. Temperature doesn't depend upon mass. So you may have a small amount of water with 100 degrees centigrade. You can also have a larger amount of water with 100 degrees centigrade. So that's intensive property. Boiling temperature. Like water is going to boil at 100 degrees centigrade. No matter whether it's 1 gram of water or it's 1,000 grams of water. It's the same boiling temperature. Physical changes. When you heat ice, we all know that it's going to melt into liquid water. If you keep on heating, liquid water becomes vapor. What is changing here and what is not changing? The composition H2O is remaining the same, from ice to liquid water to water vapor. So what is changing is the physical state. The state of the matter is changing. From solid to liquid, liquid has more, in solid, molecules are strongly bonded. In liquid, they're not that strongly bonded. And there is a larger separation. In gas molecules, H2O molecules are even farther away from each other. So what we see here is chemical composition doesn't change. Even the state of the matter is changing from ice to liquid to vapor. Still the composition is the same, H2O, and that's physical change. Now we are going to give you example of chemical changes. an iron rod, when sitting outside in presence of moisture, and of course you'd have oxygen there, it gets rusted. And rust is nothing but iron oxide, Fe2O3 and XH2O. It could be varied number of H2O. So that gives you rust. Now what kind of change is this? Is this a physical change? Answer is no, because here we originally started with iron, but we ended up with iron oxide. So composition has changed. It didn't remain the same. Uncertainty in measurement. So we need to define what is precision, accuracy, and how are they different. Precision means when you're doing an experiment more than once, how reproducible are your values? Accuracy, how correct you are when you get the values. I may have a good precision, but my accuracy could be bad because my measuring device may be faulty. So make sure you understand the difference between precision and accuracy. Precision means, is it reproducible? But we're not talking about whether each value that you are getting is a correct value or not. That's determined by accuracy. So at the bottom I made that comment. Precision means that you can do something reproducible manner and maybe right or maybe wrong. If it's right, then it's also would have high accuracy. Now significant figures. Leftmost non-zero digit is the most significant figure, and let's put down a number here. Say 1.2346. Leftmost non-zero, that's most significant. So I'm calling it MSF. When there is a decimal point, the rightmost digit, it could be 0. So that's going to be least significant figure. The number of digits from most to the least is the number of significant figures. So in this case we have 1, 2, 3, 4, 5, 6. We have 6 significant figures in this particular case. Here you're seeing two other examples of significant figures. 12.3100. So leftmost 1 is the most significant figure, and since we have a decimal point, go to the extreme right. That's the least significant figure. And now you count all those numbers, and that gives 6 significant figures. If you see a number written in scientific notation, then forget about 10 to the power. Just focus on the number part of it. So in this case, 1.234, 1 is the most significant figure and 4 is the least significant figure. And so we have 4 significant figures. 1200 often is confusing whether we'd be considering it to have 2 significant figures, 3 significant figures, or 4 significant figures. If you look at the right hand side, 1.2 times 10 cubed gives 1200. 1.20 or 1.200 times 10 cubed would also give 1200. So the question is, which one would be the answer? Because if you have the first number, that would have 2 significant figures. Second one would have 3. Second one means this one, 1.20, 3 significant figures, and last one would have 4 significant figures. It all depends upon how you came up with 1200. If your machine gives you 1.2 and your multiplicative factor for that machine is 1000 or 10 cubed, then you would have only 2 significant figures. On the other hand, your measuring device may give you 1.200 and then your multiplicative factor could be 1000 or 10 cubed, then you'd have 4 significant figures. So when the question is 1200, your answer would not be specific. It could be 2, 3, or 4 significant figures. Now, if the number is 0.00520, you can write down in scientific notation to help you understand it better. So leftmost would be 5, most significant figure would be 5, least significant would be 0. So there are 3 significant figures. Now we also need to know what are exact numbers. 12 inches make a foot, so 12 represents an exact number. Exact number means infinite number of significant figures. So basically, even though we say 12 inches make a foot, but actually it's 12.0000, all infinite number of zeros at the end that makes a foot. Rules of multiplication division. Say you're multiplying 1.0 by 5.3642. 1.0 has 2 significant figures because 1 is the most significant and 0 is the least significant. 5.3642 has 5 significant figures. When you multiply that number, first write down what your calculator is giving you, or you can also do it without using a calculator. 5.3642. Then the rule is, if you're multiplying or dividing 2, 3, 4 numbers or a number of terms, then go by the smallest number or minimum number of significant figures. Your final answer can have only the minimum number of significant figures of the multiplying or dividing numbers. In this case, the minimum number of significant figure would be 2. So my final answer should be rounded off, keeping the first 2 figures. So it would be 5.3 and I need to drop 642. Then we need to apply round off rule. 6 is more than 5, so I need to add 1 to this number 3. That's why it became 5.4. Now what are the round off rules? When dropping a digit greater than 5, add 1 to the preceding digit. When dropping a digit equal to 5, add 1 for odd preceding digit. Otherwise, do not add anything. Rules of addition, subtraction. In addition, subtraction, you go by the minimum number of decimal places. So you'd be focusing here on decimal place. Like 0.1 has 1 decimal place. 22.32 has 2 decimal places that I'm underlining. So your final answer should not have more than the minimum. So the minimum is 1 decimal place. So I'm allowed to keep only 0.4 and drop the rest. Since what I'm dropping is less than 5, so I don't add anything to the preceding number. So the value is going to be 22.4.